I want you to definitely stick around for this next speaker. I was listening to him yesterday. Very succinct, to the point, amazing speaker. I think you're really going to enjoy it. His name is Douglas Mallette. And to go a little bit through his bio, Douglas is a former systems engineer for the United States Space Shuttle program and is now pursuing a startup as his own company, Cybernated Farm Systems, which is dedicated to using science, engineering, and technology to help humanity by using 21st century capabilities to quell the global hunger problem once and for all. Additionally, Douglas is a published author, a book called Turning Point, which discusses how space exploration and development is vital to the future of humankind. And lastly, Douglas is an accomplished public speaker. He's spoken at venues in Switzerland, Liverpool, United Kingdom, University of Illinois, and most recently completed the Scandinavian lecture tour, covering 9 lectures in 6 cities over 19 days from Stockholm to Oslo to Copenhagen. Combining his space exploration background with his love for humanity, his lecture relates to how science, engineering, technology can be better used to help improve the lives of all the people of the earth and usher in a new era of peace and prosperity for all mankind. So please, Douglas, you're up.
Are we having a good time? Good, good. I'm glad I got some enthusiasm. The zombie apocalypse isn't supposed to be till the end of the year, so I was hoping everybody wasn't going to be like, so that's good. All right, so we went through the introduction, so let's get into the meat and potatoes of what we're going to discuss. Of course, now I get to come up after Federico and James, so great. Thanks, guys. Appreciate it. Not that there hasn't been a standard set. What I'm going to talk about is basically related to my passion, space exploration and development. I have been passionately involved in space exploration ever since I was a child, which is what motivated me to become an aerospace systems engineer, which afforded me the capabilities to work with the space shuttle program and see how things operate on the inside. This actually is what benefited me to understand what the RBE was all about. Because when I saw Zeitgeist Addendum and I saw the solution sets offered by the Venus Project towards the end of the film, in my brain I went, well, yeah, that's how a Mars base would have to work. In fact, if you were to talk to most people in the space industry, those principles and those characteristics are taught. That is how we run things. And so the ability to go from one medium to the other wasn't a very large leap for me. So what we're going to do is we're going to talk about space exploration and sustainability and kind of discuss how those things are comparative and brought together. And we're going to do it with the Mars-based thought experiment. Now, this is something that most people typically don't do at their home. They don't think about space exploration in this way. But I want you guys to think for a moment, what would be necessary for a group of astronauts to survive on a hostile world that has 2-year, at the earliest, logistic windows, which means you can't get resupplied easily by going to the grocery store down the street. There is no grocery store down the street. So what kind of practices, what kind of things need to be covered for the astronauts? Well, there are really 2 primary sets of conditions. You have your biological needs, the things that keep the creature known as the human being alive, and you have your quality of life needs, the things that make life just a little bit above standard. And so these processes have been thought about already. The Apollo program was not supposed to be a flag-sticking one shot to the moon, yay, we did it. There were plans in place to build a moon base. There were thoughts and panels and discussions on how to provide for astronauts for long-duration missions to the moon. These logistic operations happen today with the International Space Station on a regular basis. And so this isn't a foreign concept. In fact, since the 50s, if not earlier, these concepts, thanks to science fiction writers such as Isaac Asimov and many others, have been thought about. So what are the basic necessities of life? Well, here's a good list: air, food, water, sleep, and medical care. The last 2 a lot of people seem to not think about. If you don't get quality sleep, that does have a detrimental effect to your biology, psychologically and physically. And when it comes to medical care, it's pretty obvious. If you get broke, you've got to get fixed. Now, what about our quality of life? Shelter, clothing, education, energy, transportation, communication. A lot of people can understand these. Now on Mars, well, now that's a little bit different for shelter, isn't it? It's not like you can take a brisk morning stroll in the crisp Martian air. It doesn't quite work that way. So your shelter is a biological requirement to keep the astronauts alive. And likewise in the International Space Station, and that in a way kind of ties together clothing and shelter, because those spacesuits that the astronauts wear when they do an EVA or an extravehicular mission outside of the space station, they need to wear basically a shelter in a suit so that they can exist and perform the functions that are necessary outside of that habitat. So a lot of thought has gone into how do you sustainably do these things, because it's very important to remember, it's not like the technologies and the knowledge that we gain through space exploration stay in orbit. These things are designed by people on the ground, tested by people on the ground. They are developed and put to test on Earth to be used in space. So if we can do it up there, why can't we do it down here? There's also something else to consider. You can't just take 100% of what you need up in space. It doesn't work that way. If you run into a shortage in space, people die. It's really that simple. Likewise on Earth, especially when you look at the scarcity paradigm that has already been alluded to the previous lecturers. So abundance, when we do engineering, we don't do something to 100% of specification. We do something to 120% of specification, 150% to specification. It's an overage. It's a contingency plan. You have backups. Do you think the space shuttle only has one flight computer? Well, of course, the space shuttle's not flying anymore. But do you think the space shuttle did only have one flight computer? Absolutely not. It has three, and they're all redundantly connected. You have to have backups. You have to have redundancy. You have to have abundance. But when it comes to space exploration, we have technical abundance. You see, there's a big difference. You go back 50,000 years to the hunter-gatherers of man. They lived in a paradigm of natural abundance. A really big planet, not a whole lot of them. So it was pretty easy for them to yank whatever they needed wherever they went. And that's exactly what they did. They'd stay in a place for a particular time, hunt what they could, pull what they could from the trees and bushes, fish from the local stream, and when they kind of ran out or the weather changed, they moved along. They lived in a natural abundance paradigm where the Earth was perfectly capable of providing everything that they needed to survive. Over time, as populations started to grow and we became a little more advanced, we have started to put a strain on the planet. And so, thanks to our wonderful brains and our innovative technical capabilities, we have developed technical abundance solutions, which mimic nature in very specific ways so that we can provide enough for every man, woman, and child on the planet in the same way that Mother Earth did it 50,000 years ago for a much smaller population. And when it comes to a Mars base, that is absolutely a necessity. So now, let's talk about some of our technologies for biological needs. Now we're going to focus a little bit on Earth, but I'm going to kind of jump back and forth between the Mars base and the Earth base that we live on. Air, well, that's pretty naturally abundant as long as we don't muck it up, right? And we're doing a pretty good job of polluting the air, but there's also a concerted effort going into making sure that the air we have is the cleanest possible and that we do things the right way. Now on Mars, there are ways to synthesize and manufacture air, such as electrolysis, which splits water into its contingent components of hydrogen and oxygen, and you breathe the oxygen. And you use the hydrogen as a fuel source. So there are ways on another world to make that happen. This is also why water is so important to find on Moon, which is why we did the L-Cross mission, which a lot of people thought was bombing the Moon, which was the most comical thing I'd ever seen. But considering the fact that the Moon is bombarded by asteroids on a regular basis on the backside of the Moon, people forget that the Moon is the Earth's shield, and it actually sucks up a lot of the rocks that want to come and hit us. So us flying a little dead SUV-sized slug into the moon to see how much water it has on it, it's really no big deal for the moon. Now you've got water, getting back to that. Now on the Earth we have desalination plants. We have many tools and ways. And I don't necessarily mean old school desalination systems. There are clean energy ways, solar power ways to desalinate water and transport water. And I'll give an example using the NASA spinoff technology. There's a nano mesh that they've created where you can take a bottle of water. Let me get a fresh one, because this ain't mine. You can take an empty bottle of water, go to the slimiest mud hole in sub-Saharan Africa, run the bottle through, and have this stuff that you definitely would not want to drink. But you run it through this nanomesh material, and out through the other side comes water that you can unscrew the cap and drink directly from the same bottle. Because the nanomesh material literally filters out everything but the water. We have the technological capabilities to do that. There's a bottle called Water for Life. This was developed in part with NASA help. NASA creates this spin-off magazine every year. A lot of people don't know about it, but they've been doing it for decades. And it talks about direct NASA innovations that are applicable to everyday life on Earth and how they have worked with industry to, again, work on projects that have impact on people's everyday life. Like, I don't know, the CAT scan machine, thanks NASA. MRI, thanks NASA. Kidney dialysis. I mean, the medical industry is loaded with space-based applications that were derived because of the NASA program. Then you've got food. Now, this is something that I have personally taken on as a way to make a positive impact after I got released from the space shuttle program. You see, I could have gotten a job working with some military contractor doing missiles, bombs, and guns, but I'm not exactly interested in that. So what I've decided to do is put my systems engineering capabilities and merge them with aquaponics systems to create high-tech farms. In short, the goal is to solve the global hunger crisis once and for all by creating fully automated aquaponic farm buildings that are off the grid, self-regulating, self-sustaining, clean energy powered, collects its own water, regulates itself. I can drop it in the middle of nowhere, and it will feed about 1,000 people, 10 different fruits and vegetables each, constantly for 50 plus years. You see, a lot of people talk about the transition, and they're like, how are we supposed to get from here to there? Well, one of the best ways to do it is to just practice what you preach, isn't it? Let's start developing companies and organizations and institutions that use the existing system with the intent of eroding the existing system. Now we can talk about medical care. That device that you see on the left is called the Da Vinci Surgical Assistant. Basically, the surgeon, as you can see, sticks his head in a big Nintendo device. And he starts playing with these little bells and whistles that he's got there at his fingertips, and this surgical assistant has now gone global. It makes surgeries tremendously more precise. The recovery times are 50 to 75% faster than normal. The incisions are smaller, and scars are almost gone as far as how these surgeries are done. And we're talking cardiac surgery. We're talking about throat surgeries, a lot of medical terms that I can't pronounce and don't care to. But you can look up the Da Vinci Surgical Assistant yourself and see lots of videos and testimony as to how amazing this is. It's kind of funny how this was developed. This was actually a military operation, so that this robot could be put in the battlefield and surgeons back at a safe home base could tele-remotely control this surgical assistant and work on wounded soldiers. Of course, the mainstream medical industry said, hell, well, why don't we just do that in hospitals now? And that's exactly what they did. And even more so, imagine putting this in a third world village in the middle of nowhere, and so you might not be able to send a surgeon directly out there, but you sure as hell can send a machine. And so any surgeon anywhere can connect to this system through telecommunications and be able to save people's lives without necessarily having to travel there to do it. Now, what about technologies for quality of life? If you notice, I skipped the sleep one. Well, if you've got food, shelter, and clothing, and water, and a lot of your needs are met, sleep comes by a hell of a lot easier, doesn't it? Technology for quality of life. Well, thanks, Fed, for stealing my contour crafting thunder. But Federico touched on it. He talked about contour crafting, the ability to build a 2,000 square foot home in 24 hours. I ended up contacting Dr. Kushnievis shortly after the Haitian earthquake because I saw the potential of what was going on and what that could mean, and then come to find out, of course, the primary restriction from him being able to develop a full-scale prototype was... Ah, very intelligent audience. All right, good. Yes, money. He doesn't have the financial backing to build a full-scale prototype. So through a little poking and prodding, I ended up putting him in contact with Peter Joseph, and the next thing you know, he is in a film. Now, clothing and other products. Well, we talked about 3D printing, which is something Federico also stole from my thing. But that's okay. I have props, and he doesn't have props. These are actually 3D printed materials that I got from Bergen in Norway when I was on my Scandinavian lecture tour. I was able to visit a company that does prototype 3D printing and manufacturing. This is a tool or some kind of widget that they devised, and this is another material that actually has threads. That's how detailed this can get. You can create wrenches, you can create custom tools, you can create cups and plates and silverware, and I also have pictures of titanium 3D printing systems. Yes, we are now getting to the point we are beyond plastic, and we are starting to use metals to do that. So imagine living in a world where you custom design your own pots and pans, and you have them custom manufactured for you, and they are sent to your house, and you're not necessarily restricted to what somebody else thinks is the best design for your kitchenware, but you get to be your own designer if you want to. Or you could peruse a whole bunch of options and blueprints and pick the set that you want and only have that manufactured, so that we no longer have this case of making a whole bunch of product and then advertising the hell out of it to guilt trip people into buying it. You only create what you need. Now, communication, it's very difficult to argue against how dynamic and amazing the communication systems are that we have around the world today. I mean, babies these days are born with an umbilical cord with an iPhone attached to it, for crying out loud, or some kind of smartphone. So that is unquestionable in today's day and age, which of course goes right back to education. Now, I know that James touched base on the educational paradigm shift very eloquently, an excellent presentation. I will add to it, with communication and the education combined, there are websites such as khanacademy.org. For those of you who don't know what Khan Academy is, it is a free online software, a website that you can go to, and you can learn pretty much any hard science that you want, and they are currently partnering with Google in a way to try and get history and English and other subjects to follow the Khan Academy format. But I'll give it to you in a very short kind of bullet point idea. It's a tree format. Let's say we're doing math. The very first lesson is Math Edition 1. 1 plus 1 is 2. Kindergarten stuff, starting at the beginning. It goes all the way down to advanced trigonometry, differential calculus, and linear algebra. It goes very complex. And as you pass these lessons, but here's the catch, there's no grades. You have to master a subject before it unlocks the next subjects. So these short 10-minute videos, you watch this short video, which is better for the human brain. We don't want to sit for 45 minutes watching an instructor drone and drone and drone. So you get these 10-minute videos on a particular topic. You do the lesson. You have to answer 10 questions in a row accurately, and that is what allows you to move on. And throughout the process, you earn badges and points, and there's kind of a game system to it, so it's also fun to do. And it's great for kids, such as my daughter. I have an 8-year-old daughter now. Her name is Angelique. And when she was about 6 and a half, we decided to put her on Khan Academy. And so 6 and a half years old, I don't really have to monitor her because that's kind of the point. It's a self-directed, learn-on-your-own system. So we taught her how to basically use it. It's very intuitive. It's easy for a young child to understand. And we'd cut her loose on that every other day or so for about 30 minutes. About a month or two into it, she comes up to me one day and she goes, "Dad, I'm having a problem with a word." And I'm thinking to myself, a word? You're doing math. What do you have words for? And I go, "What are you talking about?" And she's like, "What's obtuse?" And I'm like, "Obtuse? You mean obtuse?" She goes, "Yeah," and runs off. So I'm thinking to myself, obtuse, as in obtuse, acute, right angle, early trigonometric identities. So I walk over there, and I look over her shoulder. Yep, that's exactly what she's doing. She had already passed the lesson on degrees and radians, understanding what the difference is between degrees and radians, and had moved on to geometry and early trigonometric identities. And when she passed that lesson, and she did, she moved on to Pythagorean theorem, sines, cosines, and tangents. Of course, I had to put her on pause a little bit for that, only because she had completely stopped doing the subtraction and on that side of the tree, and she just started going down that side of the tree. So I had to kind of get her to, you need to do a little bit of, 2 minus 1 kind of stuff a little bit. But nobody, and I didn't tell her it was wrong. I said, "That's amazing. Now let's go up here and do some of these ones." And she's like, "Okay." And so she started moving down the other side. Now she's doing 3- and 4-digit addition and subtraction, and she's doing single and double-digit multiplication. She's 8. Because this system, it's like a supplementary course, and they're testing it in California, working with the teacher as a referee in the class, not an authority figure. And the Khan Academy is being used so that the students can work with each other and teach each other, and there are 8th graders doing differential calculus. And they don't know that they're not supposed to be doing differential calculus, because nobody's telling them, well, that's a senior or college level course. Screw that. If they have the potential and the passion and they get to that level, do it. And of course, we all know, as education goes, so goes society. So now let's talk about one of the biggest ones, right? Energy. We have an energy problem. Oh my God, the world's going to fall apart. We're short on energy. No, we're not. We have a common sense problem. Clean energy solutions are a part of the puzzle that need to be used in concert all together. It's not like we're trying to come up with one holy grail solution of cold fusion that's going to solve everything. All right? What you need is a reasonable approach based on geography, based on location, based on what's available, and mix a whole bunch of technical systems together to provide for the energy needs of a city or a home or a region. So we've got things like solar power. Everybody knows about good old-fashioned solar, and just recently, bottom left, photovoltaic paint, which is why you have a solar panel with some paintbrushes, right? So you can paint your home or car, and it will be the solar collector because of the nanoparticles that are involved. That's a pretty cool invention, don't you think? And recently on Zeit News, which was a website that I helped develop when I was the technology team lead, Zeit News posted recently well, thank you. Zeit News posted recently an article about a photovoltaic cell that works at night. It collects heat, thermal energy that's radiant throughout the evening and converts that into electricity. So now you've got solar panels that work at day and night, and you can paint them on, and you can put them in windows. You have photovoltaic windows. You get a friggin' photovoltaic clothes thanks to nanomaterials. So there's no shortage of solar options. And you've got solar roadway. Now this is an amazing technology in and of itself. I have a link on the bottom. So if somebody wanted to go to solar roadways and look at some of the numbers, but let me just put this in short. If solar roadways were to replace all the major highway systems in the United States, we would be able to power the energy needs for the entire planet 2 to 3 times over. We have an energy problem? No. We have a common sense problem. Not only that, but these roadways are obviously not based on fossil fuels because asphalt is created as a petroleum derivative. And if you do these as solar panels, which is glass made out of sand, so yeah, that's a lot easier to deal with. You also mitigate a lot of the dependency on oil and fossil fuels for just your basic highway and road systems. Now you've got 2 kinds of wind, small scale and large scale. Now small scale wind systems, see, I'm not really a big fan of gigantic fans in the middle of nowhere that spin around and have huge distances in between them that are also hazardous to birds, other animals, and heaven forbid gravity actually pull down the blades so it ruins the gears on the top and they freeze or stop because they break down. Or they're directionally dependent, which means they have to face the wind in order to spin. I'm more interested in vertical maglev wind turbine systems that are directionally independent of the wind, which means it doesn't matter which way the wind is blowing. These things always spin in the same direction, thanks to good old-fashioned aerodynamics. And because they're maglev, they're floating on magnetic bearings, there's no friction involved, so that you can have a much lower wind cut-in speed, which means you can blow on it, and it will spin. So you put these things on a 15-foot tower on the top of your house where the wind speed is about 17 or so miles an hour on any average day, and you have the potential of creating a pretty good energy system for your house. You mix that with a little bit of solar and a little bit of geothermal, and based on where you live, a little bit of hydro, etc., there is no energy problem. If you look at the picture on the right, heaven forbid we actually put these on the light posts that are going down the highway. What happens when a car drives by? Generates a pretty good gust of wind, right? So now you have an electric car system so that when the cars drive by, it spins these vanes. Either direction the cars go, the vanes spin in the same way. During the day, it charges batteries at the bottom of the post, which will light the lights during the day, so every light is independent. So now we don't have to worry about power outages or grid fallout issues. So if something happens somewhere else, it has no effect on the lighting, so people can see where they're going, and that increases safety, right? And you can run the entire highway lighting system off of these. And then you've got the big dogs. You got design systems that are out there. And by the way, for anybody who thinks I'm blowing smoke, I have a magazine in my book bag. It's from 2008, Popular Science, that talks about these in 2008. Less than 5 mile-an-hour wind cut-in speed can serve over 750,000 homes with just one of these large-scale vertical wind turbine systems. And if you put a cool little restaurant on the top, maybe a little motel or something, or a helicopter pad or whatever, you could make it an attraction in and of itself, while it also serves the needs of the energy for the city that it's taking care of. Then you've got wave power. Waves go up, waves go down, waves go in, waves go out. What that does is push wind. So the thing on the right, the picture on the right, when the waves go up, causes wind to go one way. When the waves go out, it pulls the wind the other way. And the turbine on the inside spins the same direction all the time, no matter which way the wind is going. So in effect, it's like your lungs, breathing in, breathing out, and every time that happens, that turbine spins. And if you do this in the right way, you could make these very beautiful, artistic parts of the landscape, part of the beach, so that it would actually be an attraction and not an eyesore if it's done the right way. Heaven forbid we actually combine artists and engineers to make things amazing. And then we have our tidal systems, basically it's turbine spinning thanks to the flow of water. I mean, water is just a medium like air, so if wind systems can make fans turn, water systems can also make fans turn. And so when the tides go in and out, it can also create energy. The one on the bottom left, if done in the right way, could be turned into an artificial reef and might actually be a good bonus to the ecosystems that we're destroying in the first place, and it could generate energy at the same time. Geothermal, something that Iceland uses a lot, and there are geothermal vents all over the place that can be tapped. Again, regionally specific solutions that are most appropriate for that area of the planet. You start using geothermal with a little mix of everything else, and you can definitely power individual homes in a smart grid system. Imagine a grid where you don't have, it's so funny, we get attacked a lot, right? Communism, central planning, you know, you've got all these authority figures on the top. Do you think the power systems that we have today aren't the most centrally planned, centrally controlled bunch of crap you've ever seen? Just ask Fukushima how that works. I mean, you lose a nuclear plant, entire half of a country goes down, and not to mention the fallout and the natural disasters and just built into that alone. We are highly centralized in the way we do energy production, and it's highly monopolized. I have one power company to choose from where I live. Oh, thank you, free market. Bullshit. So, what if every house was a partial contributor to the grid? What if every building had a little bit of solar, a little bit of wind, some photovoltaic paint, you had your roads, you had this dynamic infrastructure, and it was a smart grid where let's say you have one building that's generating 150% of its needs because everybody went home early, whatever reason, and you have another building on the other side of town that is 50% deficient on what it needs. The smart grid system will automatically funnel the energy surplus that that one building is creating to the other one, and they'll do it like that. This is my most fun one, piezoelectric. The dance floor on the upper left is being lit and powered by the people dancing on the dance floor. Piezoelectric basically uses vibrations, and that can generate electricity, and so as you're walking or dancing or whatever the case may be, you can generate power. So the people on the bottom right are standing on what effectively could be an artificial sidewalk or just a sidewalk with piezoelectric sensors in it. I want you to think about a high volume traffic area, say in like New York. Imagine if a New York sidewalk was piezoelectrically wired. Imagine the footsteps. If you had 100 people a minute only generating a half or a quarter of a volt of energy, just do the math. You're going to generate a crap load of power just by people walking on the sidewalk. And since we want to develop a world where people are more active and not sitting on their butts all day and they're out walking around and doing stuff, every sidewalk and every major walkway throughout the entire planet could be piezoelectrically wired in conjunction with all of the other energy solutions that I've just talked about. We don't have an energy problem. Fuel cell systems are pretty darn amazing, especially the Bloom system, which just recently came out. It is primarily made out of sand. It's very, very robust as far as its potential. Currently, it does work on natural gas, which is still better than some of the other fossil fuels, but they are working on a way to make it clean energy powered through solar or other means, and that's going to happen. It's going to happen anyway. But if you look at some of the statistics on how these things work, one fuel cell can power a light bulb. You stack a few of them, you can power a house. Now look at the size of that stack in that person's hand. That could power your house, 40 of them. You put a whole bunch of them together like a refrigerator and you can power a Starbucks, which I love. Or you do a larger server, which is the size of a parking lot, and you can power up to 100 homes. Plus a little wind, plus a little solar. Gee, I sound like a broken record, right? Now let's talk about some transportation. Now, we got electric cars. The Nissan Leaf is coming out. I kind of like Tesla's sporty look a little bit, so, you know, we've got those options as well. And one of the biggest arguments against electric cars, of course, is that we don't have the infrastructure in place to recharge these things. Last time I checked, when the internal combustion engine was developed and cars were being made, nobody said, no, you can't invent the car yet. We don't have all the gas stations in place. It didn't work that way, did it? Yet all of a sudden now we're supposed to believe that that's how it's supposed to work, that we have to have all the gas stations in place before we're allowed to build the car? Screw that. No. You build the car and you retrofit and you phase out the crap gas stations that use fossil fuels and you implement the battery swap stations and the recharging centers that will allow the electric car to be the robust primary mode of transportation for the planet. Thank you, Fed. So I think we covered the robotic GPS-driven car. It's okay, you're making my lecture go a little quicker, so that's fine. You also have additional systems like the Ultra Transport System, which is currently in test at Heathrow Airport, where you hop in, it's an A to B, almost like a taxi system. It's not on a free road, but it does follow along a preset primary path. So you just tell it where you want to go, and if the city is designed properly and it has a good highway system designed for these vehicles, you just hop in, press a button, read a book, and it'll take you where you need to go, point A to point B. It's not like a bus, it's more like a taxi, but it's automated. And these already exist. In fact, I don't talk about anything that I can't prove in some kind of way through research, statistics, links, or data. So, and I do have a source sheet for all of this. And if anybody wants the source sheet, find me on Facebook, Douglas Mallette, email me, and I'll send you the source sheet. Then you've got bullet train systems, maglev systems, evacuated tube transport, which is basically a vehicle the size of a small van or a car that can hold 4 to 6 people. But you put it in a vacuum tube, you suck out 50 to 75% of the air. It doesn't have to be a hard vacuum-like space. You just want to reduce the drag enough so that that cool little pod can go, I don't know, 1,500 miles an hour. And it can be run on clean energy systems just like everything else. And you can go from New York to Hong Kong in, I don't know, 6-7 hours maybe or less. Well, it depends. You got to accelerate at a reasonable rate and decelerate at a reasonable rate. You go from 0 to 1,500 too fast and you're going to have a damn headache. So let's think about this. There's all kinds of solution sets out there that mitigate the energy problems, the transportation problems, allow us to be cleaner and greener with how we get around, allow us to build homes relatively quickly for emergency situations. I mean, it's not like we don't have a surplus of housing anyway. There are more than enough homes in existence today to cover the needs of most of the first world, and we could use these advanced technologies to help the, I don't want to say developing world or developed world. Those two words are kind of finite. Just help others in need. So after such abundant solution sets are implemented, there's a question. Can this current system handle that level of global sustainability? Now, I know a lot of you know the answer to this one. No, it can't. It was never designed to handle that level of efficiency, to handle that level of global sustainability. And so what I've done is I've kind of gone down and broken down some key elements here. What do we have now, and what do we need? What we have now is a system based on scarcity, and what we need is a system based on technical abundance. What we have now is a system based on inefficient human labor as the main driver. Federico touched on this perfectly. A system, what we need is a system based on efficient technical labor as the main driver. Falling away are the days of human labor for income to survive. I do not find it unreasonable that every man, woman, and child born to this earth should automatically, by default, have abundant access to their biological and quality of life needs so that they can grow up and be the most productive, positive, amazing people this planet has ever known. We have a system based on cyclical consumption for constant growth. We need a system based on sustainability and balance. How many Earths do we have? How can you infinitely grow on a finite planet? That's retarded. It doesn't work. So how do you expect an economic model to operate under that kind of thinking when you only have one planet and a certain amount of stuff? What we need to be doing is reuse, recycle, efficiently recycle. We don't exactly even do recycling very well these days. And I don't necessarily mean people participating. I mean some of what we recycle is energy inefficient. Just the recycling process is crap. And so those need to be revisited as well. Some people get the good old feely warm thing inside. I'm recycling, I'm green. You realize some recycling practices are more energy inefficient than the original production of what you're trying to recycle. A lot of people should do more research as to what is worth recycling and what really isn't. We have a system based on ownership and control. We need a system based on usership, which I kind of made up, and open access. Well, that one kind of makes sense. I mean, if you look at where did ownership come from? You go back a couple of thousand years, of course, that's kind of the system we're using, isn't it? Let's go back to the agricultural revolution, which is a little bit more recent. You had Farmer John sitting down doing their work, and that was very human labor intensive. A lot of blood, sweat, and tears and emotion goes into it. There's an emotional connection to that labor. I worked hard for this. If some random schmuck comes up and starts taking all the food and walking off with it, that's likely going to piss you off, right? You put a lot of work into that and somebody just comes up and takes it. So you put a fence around it. Now I own this land. This is mine. And then if they hop the fence, you hire a security group. You get a couple of guys with some billy clubs to protect that land. Hello, police and military. So you can see where all of that starts to develop from just the simple practice of growing some food, but trying to maintain control over that. Now those concepts have graduated to so many different aspects of our lives that it almost seems normal when, quite honestly, it's abnormal. We should be more open source, open access, and sharing of information so that that schmuck who tried to take food from you doesn't need to take food from you. They can get their own. Or the systems are so robust that there's such a surplus of food, there's no need to steal in the first place. If you modify the environment, you can make it such that people don't even think of exhibiting aberrant behaviors because it doesn't make sense. We have a system based on outdated, multi-century-old ideologies and institutions. I think we've pretty much hammered that one pretty good, right? What we need is a system based on forward-thinking, adaptation, and emergence. Things are always changing. The earth is flat. I know it's flat. Look, damn it, if you look down there, it just and stops. And if you go over there, your ass is going to fall off the edge. Go around the world, okay, a little bit of science, not so flat. New data, new information, new way of thinking about things. There is no way we are ever going to go into space. Are you crazy? Besides, that's flat too. Look, you can see it kind of like, it's just kind of up there and everything looks like it's in the same place, right? So there's no way we're going to go up there and go into space. Tranquility Base, the Eagle has landed, man on the moon. Okay, maybe we can go into space. New data, new information, new way of thinking. We are constantly upgrading what we think we know versus what we do know, which is why I love being a science techno-engineering geek, because in the sciences, good scientists are always challenging what they think is the norm. Is E equals MC squared still valid? Let's test it. And constantly go back and retest it. Because one day we're going to break it. And when we break it, we're going to develop a new way of understanding the universe, a new way of understanding nature, and that's only going to make us better. That's how the process works. Adaptation and emergence. Right now we have a system based on hostile competition, secrecy, and differential advantage. What we need is a system based on cooperation and collaboration. You see, I don't actually personally have a problem with competition, friendly competition. In fact, I am currently in competition with my best friend for physical fitness. I have a goal in a month and a half of being more in shape than he is. I'm at a disadvantage because he is genetically prone, being this taller Italian jackass, of just genetically having this ability to just be in better shape. I mean, he used to be a Chippendale dancer, for crying out loud, and I'm challenging him in a physical fitness to get in shape. But you know what? That motivates me. Of course, whoever loses has to do a mile in a dress. So I hope I win. But see, that's friendly competition. That motivates you in a positive way. Because at the end of the day, what's it going to hurt? When I'm going to run a mile in a dress? You know what, though? I'm going to be one physically fit, dress-running son of a bitch. Right? At least as close as possible. I might not beat him, but I hope I tie him. And so, and likewise with the sciences, two scientists competing against each other to solve a problem. At the end of the day, the problem is solved, mankind is better for it, and those two scientists can hopefully go have a beer together and shake hands and understand what the real goal was. But economic competition in today's world kills people. And when you have that kind of competition where resources are hoarded, manipulated, wasted, and misconstrued in ways for the sake of profit and constant growth, people die. That kind of competition sucks. That's the kind of competition that we don't need anymore. But I'm okay with some friendly competition. We have a system today where political opinion, influenced by financial contributions, dictate the ebb and flow of global operations. And we know this to be the case. That's how the game is played. I don't buy into all the conspiracy theory crap that there's a whole bunch of nefarious organizations controlling and manipulating. No. People are just playing the game really well. And if they want to get together as a group and collaborate and play the game that way, that's fine. I don't fault the people. The game sucks. And so our job is to change the damn game. And you can do it a lot of different ways. These are ways what we're doing it here, getting the awareness out. It's an erosion from the bottom up of getting people used to and adapted to technical solutions that better their lives. That's why I'm doing cybernated farm systems. People can do that for energy or transportation. There are ways to erode the system from the bottom up to lessen people's dependence on money to survive. That's the whole point, isn't it? Erode that dependency on money to live, and eventually money becomes pointless. And that's what we're trying to get to. Rome wasn't built in a day, fed, but it is a process that we can undertake as a group, as a globe, as a collective, working together to better mankind in our own way. Do what you're passionate about, and do it with the RBE in mind. That is where you get to the point where the scientific method, in conjunction with human experience, the arts, technical foundations, things like that, will enhance the lives of all people. Mankind needs to improve to a new and upgraded global operating system. Right now we're using Windows 1.0. We need to upgrade to Linux. But remember, there are no utopias. I hate that word. Oh, hate is too strong of a word. I strongly disapprove of that word. There are always going to be problems to address and ways to improve, new challenges that we're going to come up with, I don't know, like maybe space exploration or something like that, underwater sea exploration, going to the depths of this earth or going beyond it. Those kinds of challenges are the ones that we should be stepping up to. It shouldn't be a challenge to feed people on this planet anymore. It shouldn't be a challenge for everybody to have clean air and the ability to get around. It shouldn't be a challenge to provide energy systems that can cover everybody's needs. Those challenges have been solved. It's time to move on to better challenges. We have new tools. We develop new tools and capabilities that require new ways of thinking. And when people throw out the utopia word, I go back to Neanderthal Cousin. I don't know if any of you know about him on YouTube. He's an amazing work that he does. And he made a video called the Mars Project. It's hilarious. So try to explain to a hunter-gatherer from 50,000 years ago indoor plumbing. Now we take indoor plumbing for granted. But to a hunter-gatherer, they're going to be like, what? You turn something called a tap and you get hot or cold water anytime you want, no matter where you are, on demand, that's utopian. You're crazy. No, they're not going to understand that level. But for us, it's like every day. Well, let's not get into how is the water heated. Well, you've got, water heaters or solar or energy systems. What's a house? Well, now you have to explain what a house is. And so let's just go down that path a little bit, and you can see how crazy our world would seem to somebody from that far in the past. Fortunately, in today's world, we don't have to wait 50,000 years to upgrade the planet. We're simply moving from an established society to an emergent society. Because you see, global sustainability is something that already exists. It's something that was developed a long time ago. It's constantly being refined and redeveloped in new ways all the time, which is what zeitnews.org kind of showcases, are all these technical adjustments and these new ways of doing things. It's an amazing website that I hope many of you will be able to take a look at. A lot of people have it as their homepage, for crying out loud. We have the capabilities to do a lot, to use science, engineering, and technology for human concern. It's about time in the 21st century that we start actually behaving like 21st century stewards of this fertile planet. Thank you.